Good morning dear students, welcome back. So in my previous two videos I was talking about quantum computation fundamentals, importance of quantum computation, comparison of quantum computation with classical computation, and also something about qubit and bit, comparison of qubit and bit. Now let us proceed further. This is video number 3 on quantum computation. This is exclusively made for VTU students, Vishweshraya Technological University students, and of course I hope it is useful to even other university students also who are entering into this domain of quantum computation. This quantum computation is part of engineering physics syllabus. Okay, so in order to go ahead with the physics of quantum computation, physics of qubit, it is essential to understand the fundamentals of quantum mechanics. Already you know something about quantum mechanics. Quantum mechanics started with what is called dual nature of light. When de Broglie said when de Broglie said all the particles behave like waves, a new branch called matter wave, and then quantum mechanics got opened. It was later on developed by not only de Broglie, Heisenberg and Max Born, Schrödinger and many more, even including Indian physicist by name Bose. Okay, so many people contributed to the growth of quantum mechanics. Some of the essential parts of quantum mechanics are: particles exhibit both particle nature as well as wave nature. Second thing, all the measurements are probabilistic, no measurement is accurate, so measurements are probabilistic. Next one, in case of measurement of any two quantities simultaneous, say for example you want to measure position and momentum, you come across with some uncertainty. Yes, it is nothing but Heisenberg uncertainty principle. Please recall this equation. If delta x is the uncertainty in the position measurement, delta p is the uncertainty in the momentum measurement, then the product of these two is greater than or equal to h by 4 pi. This is nothing but Heisenberg uncertainty principle. So all the measurements are probabilistic, no measurement is accurate. So please watch my video on this uncertainty principle using the description box link given in the description box. Okay, so I will not go in detail about all these things. Anyway, I will make one more video on this particular quantum mechanics. The main intention of this video is to expose you to the physics of qubits, physics of quantum computation. See, this word quantum is much talked about and we frequently use this word, but I tell you one thing, we hardly know about this quantum. We have not understood the meaning of quantum thoroughly. So quantum mechanics is also like that. See, Richard Feynman says, I am sure, he says, I am sure nobody on this earth have understood quantum mechanics thoroughly. So just imagine, Richard Feynman is 20th century great physicist. Okay, he himself said quantum mechanics is not that easy to understand. Okay, so it requires a higher level mathematics, a lot of physics and other things. Therefore, quantum mechanics, what I am going to explain here, what part of quantum mechanics I am going to take is very, very, very little. See, you can call it as a drop in ocean. Okay, Sindhuvinalli ಒಂದು ಬಿಂದು ಅಂತಾರಲ್ಲ, Sindhu means ocean, Bindu means one drop. So only very little I am considering for the explanation of qubit. Okay, let me go ahead. So three elements or 3 to 4 quantum mechanics elements are particle and wave nature of the particle nature and wave nature both, dual nature, and then measurements are uncertain, probabilistic measurements, and the particle position or momentum or any other particle parameter are represented by what is called wave function. So wave function is symbolically represented by this letter. This is called psi. It is a function of x and t, where x is the position coordinate, t is the time coordinate, and your teachers, they have explained what exactly psi is, what exactly probability function is, probability amplitude, probability density, etc. Okay, now let us move on to qubit. Yes, in my previous video I said qubit is representation of state of a particle. Any particle you take. Now I am not going to take too many particles just to avoid confusion. I just take only one particle, that is nothing but our electron, because electron is very familiar to us. We have known electron from the childhood, so we can take electron, we can talk about electron. Dear students, you all know electron rotates about its own axis, it is called spinning, also goes around the nucleus, it is called rotation. rotation. It is exactly like our Earth. Earth goes around the nucleus, Sun, Earth goes about its own axis. Similarly, electron also. So electron rotating about its own axis is known as spinning of electron. This spin axis may be upward or may be downward, and in any given subshell, two electrons we can find. One in the upper spin, may spin up state, other one is spin down state. Okay, let me consider one particular orbit. Let us say sodium. I consider sodium, 11 electrons are there. Electronic configuration is 1s2, 2s2, 2p6, 3s1. I forget about all these things. Okay, you consider only 1s2. That means in s subshell of K shell there are two electrons. These two electrons certainly will be having spin up state and spin down state. This you have studied even in PU also. Now the question, out of those two electrons, which one will be in the spin up state, which one will be in the spin down state? This is impossible to answer. This much I know, there are two electrons and those two electrons will be definitely in the up state and down state. This is according to Pauli's exclusion principle. If one electron is in the up state, other electron will be in the down state. Understood? You cannot answer which electron is in the up state, which electron in the down state. It is equally same. This electron may be up, definitely this will be down. If this electron is down, this will be up like that. So okay, ಯಾವ electron up state allirutte anta ಹೇಳಕ್ ಆಗೋದಿಲ್ಲ. Each electron can have upper state or in the down state, means spin up or spin down. Okay, now let me consider one nucleus. This is a nucleus. Around this nucleus one electron is revolving. Okay, revolving, and this revolving electron may be having spin up state. Okay, definitely another electron will be having spin down state, or this electron itself may be spin up or next moment it may be spin down. Okay, so I take another possibility, this is spin down, so this is spin down, right? So I have two states now, spin up and spin down. If I take spin up as one state, that is ket1, this will be ket0. Yesterday I was talking, in my previous video I was talking about the quantum states. So 0 ket represents spin down, 1 ket represents spin up. So electrons orientation, spin orientation can be considered as a qubit. It is one state which can be utilized to store the information, to store the data. Okay, or another one, say for example one electron, only one electron I take. Whatever I explain for one electron is applicable for other electrons also. Okay, one electron I consider. This electron will be having energy E1. It can have even E2 also, E3 also, E4 also, any number of energies. Okay, please recall hydrogen atom energy level diagram. There is a ground state energy, next first excited, second excited, third excited, etc. Out of those two I take only two levels. Out of so many energy levels, I consider only these two. Okay, these two only I consider, and among those two, one level is ground level, another one is excited level. So ground state energy, if I can take it as ket0, excited level or excited state I can take it as ket1. So electron with lowest energy I treat it as 0, and higher energy I treat it as 1. Okay, and you all know by doing something this electron can be taken from lower level to higher level, which we all know is nothing but excitation. So that means you can flip the level, you can change the state from 0 to 1 by sending some energy. That energy, whatever you send or whatever the method you adopt, is going to be a sort of information that you are going to store. Say for example, I want to store my voice. Okay, so I convert my voice into electromagnetic signal, and that electromagnetic signal, if it is sufficient sufficient to change the energy from ket 0 to ket 1. That is enough. Okay, so this way I am going to utilize the properties of electrons at the basic level itself, or I am going to utilize the properties of elementary particles at the basic level itself. This is not only true for electron, even for proton also. Not only true for spin up, spin down, energy ground state, energy higher state, it is even true for what is called polarization also. In polarization there are what different types of polarization: plane polarization, okay, circular polarization, elliptical polarization. All these properties of the particles at the bottom level are utilized, are encashed to store the data, to operate them, to utilize them, to manipulate them for our convenience. ನಮಗೆ ಯಾವ ತರ ಬೇಕೋ ಅವನ್ನು ನಾವು ಹಂಗೆ ಉಪಯೋಗಿಸ್ಕೋಬಹುದು. Once you know the property, you can use it for your convenience and for your requirement. So in qubits, what we are using? We are using spin concept, energy level concept, polarization concept, etc. Like in classical bit 0 and 1, what we were using? Current flow or no current flow. See the difference. There also electrons, here also electrons, but there an array of electrons were simply moving. We never bothered about what actually their spin is, how they are polarized, what energy they have. We never bothered. We bothered only about how much potential difference is applied, what is the resistance, how many electrons are available, whether it is a conductor, insulator or semiconductor. ಅಷ್ಟನ್ನೇ ನಾವು ತಲೆ ಕೆಡಿಸ್ಕೊತಾ ಇದ್ವಿ. But here it is not so. Here we are not bothered about whether electrons are flowing or not. We bother about each and every individual electron. ಪ್ರತಿಯೊಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಅನ್ನ ಬೇಸಿಕ್ ಲೆವೆಲ್ಗೆ ಹೋಗ್ತೀವಿ. ಆ ಎಲೆಕ್ಟ್ರಾನಿನ ಸ್ಪಿನ್ ಯಾವ ತರ ಇದೆ, ಅಪ್ ಇದೆಯಾ, ಡೌನ್ ಇದೆಯಾ, ಗ್ರೌಂಡ್ ಸ್ಟೇಟ್ ಇದೆಯಾ, ಎಕ್ಸೈಟೆಡ್ ಸ್ಟೇಟ್ ಇದೆಯಾ, ಗ್ರೌಂಡ್ ಇದೆ ಎಕ್ಸೈಟೆಡ್ ತಗೊಂಡು ಹೋಗೋದು ಹೇಗೆ, ಸ್ಪಿನ್ ಅಪ್ ಇಂದ ಸ್ಪಿನ್ ಡೌನ್ಗೆ ಫ್ಲಿಪ್ ಮಾಡೋದು ಹೆಂಗೆ ಅಂದ್ರೆ ತಿರುಗಿಸೋದು ಹೇಗೆ, ತಿರುಗಿಸಬೇಕು ಅಂದ್ರೆ ವಾಟ್ ಟೈಪ್ ಆಫ್ energy I have to give. Okay, if at all I want to give some energy in some form, can I convert my data into that form? ಈ ತರ ಓಡುತ್ತೆ ತಲೆ. ಹೀಗೆ ಮಾಡಿದಾಗ ನೀವು ಕ್ಯೂಬಿಟ್ಸ್ ಅನ್ನು ಹೆಂಗ್ ಬೇಕಾರೋ ನೀವು ಅರೇಂಜ್ ಮಾಡ್ಕೋಬಹುದು. ನಾಟ್ ಓನ್ಲಿ ಸ್ಪಿನ್, ನಾಟ್ ಓನ್ಲಿ ಎನರ್ಜಿ, ಐ ಟೆಲ್ ಯು, ನಂಬರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಗೋಯಿಂಗ್ ದಟ್ ಸೈಡ್, ಕಮಿಂಗ್ ದಿಸ್ ಸೈಡ್, ಗೋಯಿಂಗ್ ದಟ್ ಸೈಡ್, ಕಮಿಂಗ್ ದಿಸ್ ಸೈಡ್, ದಟ್ ಆಲ್ಸೋ ಕ್ಯಾನ್ ಬಿ ಯೂಸ್ಡ್ ಫಾರ್ ಕ್ಯೂಬಿಟ್ ಡಿಸೈನಿಂಗ್. ಆಕ್ಚುಲಿ ಸೂಪರ್ ಕಂಡಕ್ಟರ್ಸ್ ಅಲ್ಲಿ ಬರುತ್ತೆ ಸೂಪರ್ ಕಂಡಕ್ಟರ್ ಕ್ಯೂಬಿಟ್ ಅಂತ ಹೇಳಿ, ಚಾರ್ಜ್ ಕ್ಯೂಬಿಟ್ ಅಂತ. ಇನ್ ಚಾರ್ಜ್ ಕ್ಯೂಬಿಟ್ ಐ ವಿಲ್ explain that chapter separately. In charge qubit we have what is called Cooper pair. Cooper pairs get into certain area. There we have what is called Josephson junction. Okay, this is a symbolic representation of Josephson junction, and we have a capacitor, we have a voltage source, and this is a simplest circuit representing what is called charge qubit, right? And we identify some region here. This is called island. And this island will be having some number of Cooper pairs. I will explain in detail later on in some other video. Into this island, how many Cooper pairs are entering, how many Cooper pairs are coming. This island will be having some number of Cooper pairs. Therefore it is called as Cooper pair box, CPB ಅಂತ ಕೂಡ ಕರೀತಾರೆ. ಅದನ್ನೆಲ್ಲ ಆಮೇಲೆ ನಾನು ಚರ್ಚೆ ಮಾಡ್ತೀನಿ. So how many Cooper pairs enter, how many Cooper pairs leave? Entering, if you take it as 0, leaving you can take it as 1. So that way also you can store the data. See, number of Cooper pairs entering and leaving can be controlled by controlling the voltage, can be controlled by applying the magnetic field. Nodi, finally it will come to magnetic field or electric field or in total electromagnetic energy. So what I mean to say, just by using electromagnetic energy we can operate on these zeros and ones. Okay, ket 0 and ket 1. So this is the physics of qubit. With this much physics part, now let me move on to mathematics part of quantum computation. Actually physics part anta bandre adike end illa, there is no end. I can go on and on and on about this for several hours together, but nimma level ge ishtu saaku. Eno Qubit ಅಂತಂದ್ರೆ it is making use of particles behavior. It is a manipulation of the properties of the particle at basic level ಅಂತ ಅಷ್ಟೇನೆ. ಆಯ್ತಾ? ಓಕೆ. ಈಗ ಮ್ಯಾಥಮೆಟಿಕ್ಸ್ ಪಾರ್ಟಿಗೆ ಬರೋಕೆ ಮುಂಚಿತವಾಗಿ ಒನ್ ಮೋರ್ ಥಿಂಗ್, ಹೌ ಕ್ವಾಂಟಮ್ ಮೆಕ್ಯಾನಿಕ್ಸ್ ಈಸ್ ಇನ್ವಾಲ್ವ್ಡ್ ಹಿಯರ್ ಅನ್ನೋದಕ್ಕೆ ಒಂದು ಚೂರು ಹೇಳಿಬಿಟ್ಟು ಮುಂದಕ್ಕೆ ಹೋಗ್ತೀನಿ. ಸಿ ಐ ಸೆಡ್ electron can be in the spin up state or in the spin down state. Okay, let us say it is spin up state only. Right now it is spin up state. Spin up state ಅಂತ ಬಂದಾಗ what is the probability of finding the particle? That is psi. That I write as ket psi. That is equal to spin up means 1. That's all. 100% 1. 100% 1. Okay. Or if it is down state, 100% 0 or 100% 0. Okay. Only spin down forever, it is 100% 0. Only spin up forever, it is 100% 1. Suppose if it is spin up, very next moment spin down, up, down, like that if it is changing, in that case, we write psi as alpha into ket 0 plus beta into ket 1. What alpha and beta are here? See, this is going to be our regular friend here onwards. We are going to make use of this equation, use it again and again and again. What is alpha here, beta here? Dear students, alpha and beta are called probability amplitudes. There is a difference between amplitude and density. Square of the amplitude is density. Like square of the intense amplitude, this is a wave, this is amplitude. Square of the amplitude is nothing but intensity. That is in the case of normal wave. Okay. So similarly here, alpha is the probability amplitude, beta is also. Alpha is the probability amplitude of 0 state, that is spin down state. Beta is for spin up state. Suppose if your electron is always in the spin down state, then alpha is 1, alpha square is 1. If electron is always in the spin up state, beta is 1, beta square is 1. For example, you are in your classroom. Okay, in classroom room number 722. You are in the classroom 722, morning till evening. If I try to find you in the classroom, I succeed 100 times, means my success rate is 100%. So their probability amplitude is 1. At the same time, if I try to find you in the college canteen, I cannot succeed because you cannot have double rule. You are not possible to be found in canteen at the same time. Say for example, 10 to 11 you have physics class. In physics class, your physics teacher is teaching some quantum mechanics or lasers or optical fibers ಏನೋ ಪಾಠ ಮಾಡ್ತಿದ್ದಾರೆ. ನೀನು ಕ್ಲಾಸ್ ರೂಮ್ ಅಲ್ಲಿ ಕೂತ್ಕೊಂಡಿದೀಯಾ. So you are very much there in the classroom number 722. So probability is 100%. So alpha is the maximum there. Now I am trying to find you in the college canteen same time 10 to 11 ಅಲ್ಲೇ ನಾನು ಕ್ಯಾಂಟೀನ್ ಅಲ್ಲಿ ಹುಡುಕ್ತಾ ಇದ್ದೀನಿ ನಿನ್ನ. That is beta. So beta is 0. What I mean to say, when alpha is 1, beta is 0. When alpha is 0, beta will be 1. So what are the maximum and minimum values of alpha and beta? Yes, you are correct. Alpha and beta maximum and minimum are 1 and 0. Okay sir, suppose if that means alpha and beta can have only 1 and 0, 0 to 1 in between any possibilities, 100% is a possibility. 0 to 1 it can take any number of values. That is the beauty of superposition. I told you now in the previous video. In qubits, we not only have distinct 0 state and 1 state, we have even in between of 0 and 1 also, that is called linear combination of 0 and 1, which is nothing but superposition. Okay, so I said alpha and beta are amplitudes. Okay, and you know from quantum mechanics, amplitude can be negative, amplitude can be imaginary. Okay, complex number. Amplitude and amplitude is a complex number, imaginary and negative. Therefore, Max Born said better you go for modulus of this. So that means modulus of alpha square or modulus of beta square. Like your teacher might have taught you, it is better to go for modulus of psi square, which is nothing but complex conjugate multiplied by complex conjugate. Okay, so this way you have to go for modulus of probability amplitude square. Why sir? What is advantage sir? There is an advantage. If you go for modulus of psi square, then there is no question of negative value, there is no question of imaginary, there is no question of complex. Everything becomes real, everything becomes positive. So therefore we give lot of importance to modulus square rather than individual value alone. Individual value we call it as amplitude, modulus value we call it as probability density. This is what you studied in quantum mechanics, particle in one dimensional box problem, please recall. So this is nothing but same that one only. So this way 0 or 1 we can represent individually, this way we can represent in a superposed state also. Okay na? So this is nothing but qubit superposed state, this is nothing but qubit individual state. Now having said all these things, let us proceed one more step further. Now something about representation of qubits. Afterwards I will come back to what is called properties of qubits. Then I will talk about the block sphere. That is also very important. Now let me explain something about mathematics of qubits. So far I explained physics of qubit. I take up little bit about mathematics of qubits. ನೋಡಿ ಈ qubits ಅನ್ನು ನಾವು represent ಮಾಡಲಿಕ್ಕೆ ವೆಕ್ಟರ್ ಸ್ಪೇಸ್ ಅನ್ನೋ ಒಂದು ಕಾನ್ಸೆಪ್ಟ್ ಅನ್ನು ಉಪಯೋಗಿಸ್ತೀವಿ. What is vector space? Let me explain this first. ವೆಕ್ಟರ್ ಸ್ಪೇಸ್ ಅನ್ನೋ ಕಾನ್ಸೆಪ್ಟ್ ಅನ್ನು ಯೂಸ್ ಮಾಡ್ತೀವಿ. ವೆಕ್ಟರ್ ಸ್ಪೇಸ್ ಅಂದ್ರೆ ಏನು? ವಾಟ್ ಈಸ್ ಅ ವೆಕ್ಟರ್ ಸ್ಪೇಸ್? ವೆಕ್ಟರ್ ಸ್ಪೇಸ್ ಈಸ್ ನಥಿಂಗ್ ಬಟ್ ಸೆಟ್ ಆಫ್ ಎಲಿಮೆಂಟ್ಸ್ which contain, it is set of elements. Vector space is nothing but set of elements which are nothing but vectors, scalars and two operations. It is a set, ಒಂದು ಸೆಟ್. ಅದು ಆ ಸೆಟ್ ಅಲ್ಲಿ ಏನೇನು ಇರುತ್ತೆ ಅಂದ್ರೆ ವೆಕ್ಟರ್ಸ್ ಇರುತ್ತಂತೆ, ಸ್ಕೇಲಾರ್ಸ್ ಇರುತ್ತಂತೆ ಮತ್ತೆ ಟೂ ಆಪರೇಷನ್ಸ್ ಇರುತ್ತಂತೆ. which two operations are? Multiplication and addition. I come to the definition once again. Vector space is nothing but a set consisting of vector elements, scalar elements and two operations, namely addition and multiplication or multiplication and addition. Okay, so vector space alli bartakanta ella elements real idre we call it as real vector space. If the members are complex, we call it as complex vector space. Obviously my zeros and ones belongs to complex vector space because psi is a complex number. I will come to that once again later on. ಸದ್ಯಕ್ಕೆ ಇದು ಕಡೆಗೆ ಬರೋಣ. ಮತ್ತೆ ವೆಕ್ಟರ್ ಸ್ಪೇಸ್ ಅಂದ್ರೆ ಏನು ಅಂತ ಗೊತ್ತಾಯಿತು, ಅಲ್ಲಿರ್ತಕ್ಕಂಥ ಎಲಿಮೆಂಟ್ಸ್ ಎಂತದು ಅಂತ ಗೊತ್ತಾಯಿತು. ದೇ ಆರ್ ನಥಿಂಗ್ ಬಟ್ ವೆಕ್ಟರ್ಸ್, ಸ್ಕೇಲಾರ್ಸ್ ಅಂಡ್ two operations, addition and multiplication. Now let me consider any one vector. Say for example, this is a coordinate system. This is a coordinate system, x-axis and y-axis. Suppose if you have a point only here, let us say it is at a distance of x1, then OP, vector OP is written as x1 I cap. You know what is I cap here? Yes sir, it is nothing but unit vector. Suppose you have a point here, say OR, then OR is also a vector. It is y1 j cap. Like that you can have even k cap also. Instead of x alone or y alone, if you have somewhere here another point, say q, then OQ will be, can you give me what is OQ? Yes, you are correct. It is x1 I cap plus y1 j cap. See here, x1 and y1 are scalars and x1 I cap plus y1 j cap combined together gives a vector element, and x1 into I multiplication, y1 into j multiplication, and these two are added, it is plus addition. Got it? So in this form we have all the conditions, namely a scalar quantity, a vector quantity, multiplication and addition. So all these put together I can write as, okay, I call this as a, say vector R. I call it as vector R. Vector R is therefore x1 y1. That means in vector space we represent the parameters in column vectors, and number of terms in the column it represents a dimension. Dimension means it is not the number of rows and columns, that way it is single column only. Here dimension means number of elements appearing that single column. If only two terms appear, it is two dimensional. Three terms appear, three dimensional. N terms appear, n dimensional. On that basis I will write I as 100. What is this 100? There is 1 in the first place, x-axis is 1, y and z-axis 0. Come on, tell me what is j then? Yes, you are correct, 0, 1, 0. Come on, tell me what is k then? K is nothing but 0, 0, 1. Got it? This is for 3 dimension. Okay, now if v, in place of r I have, okay, v, I have v. ವೆಕ್ಟರ್ ಸ್ಪೇಸ್ ಅಲ್ಲೋ ಅದಕ್ಕೆ ವಿ ಅಂತ ಯೂಸ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ದೆನ್ ಐ ರೈಟ್ ಇಟ್ ಆಸ್ v1 i cap plus v2 j cap plus v3 k cap, ಲೈಕ್ x1 i cap plus y1 j cap ಬರೆದ್ನಲ್ಲ ಅದೇ ತರ v1 v2 v3 I am writing. Now you know it is nothing but v1 into 1 0 0 plus v2 me into 0 1 0 plus v3 into 0 0 1 0 0 1. That is nothing but v is nothing but v1 v2 v3. So v1 v2 v3 are the members of the vector space and v is also member of the vector space. So I hope you got the meaning of vector space. What is vector space? It is a set consisting of vectors, scalars and two operations, namely addition and multiplication. Okay, and number and vector space are basically represented by what is called column vector, and there can be any number of terms in the single column. If there are only two terms, then it is two dimensional, three terms, three dimensional, n terms, n dimensional. Dear students, now can you tell me how many terms I need to have for qubit? Yes, you are correct, I need to have only two, because one is ground state, other one is up state. One is spin up state, one is spin down state. Or one is 0 ket, another one is 1 ket, ಅಥವಾ ket 0 ket 1. On that basis I write ket 0 as first term 1, next term 0, next ket 1 as 0 and 1. Okay, so this is the representation of ket 0 and ket 1. Sir, why you start with 1 and 0? Why not with 0 and 1 here? This is a very valid question. Andre, sir, why can't you write 0 as 0 and 1 and why not this as 1 and 0? ಈ ತರ ಯಾಕೆ ಮಾಡಬಾರದು? Why you start with 1 only? Why you start with 0 only? There is answer for this. What is that answer, you know? In the vector space there can be any number of elements, any number of elements, n number of elements. Okay, I write it here. Let me try to accommodate it in this space, or wait, I just erase this part. Okay, so that I can write I can give the convincing answer for this particular question. This is a valid question. In fact, this question, see, like this only we have to ask questions and learn the subject. Don't just accept whatever your teacher explains. See here, in a given set there can be any number of elements, but starting element must be 0 only. Starting element must be 0 only, and 0 starting 1. Okay, next everything will be 0, right? Next 1 starting element must be 0. 1 is in the second place, first number, second number, so 1. Next everything is 0. Like that 2 I want to write. Now by now you already guessed what should be the column vector. Yes, you are correct. 0 0 1 and so on. See, for 0 we have 1 in the first place, second place 1, third place 2, fourth place 3, fourth place 3, correct? Like that 0 0 0 0 0 1. Nth place will be what? Nth place cannot be n, because first place cannot be 1. 0 ಅಂದ್ರೆ 1 ಕಡಿಮೆ ಇರಬೇಕು, ಸೆಕೆಂಡ್ ಪ್ಲೇಸ್ 1 ಕಡಿಮೆ ಇರಬೇಕು, 1 ಕಡಿಮೆ ಇರಬೇಕು, ಮೂರನೇ ಪ್ಲೇಸ್ 2 ಇದೆ, ನಾಲ್ಕನೇ ಪ್ಲೇಸ್ 3 ಇದೆ, nth ಪ್ಲೇಸ್ ಅಂದ್ರೆ n minus 1. So this is the way of representing the states. This is the way of representing the states. Okay, but anyway I want only first two numbers. I restrict only to this, therefore it is 1 0, therefore it is 1 0, and then I restrict to this, that is 0 1. So it cannot be 0 1 like this and 1 0. It must be 1 0 for ket 0, 0 1 for ket 1. I hope you got the concept of representation of qubits using column matrix. Understood? So this is the beginning of mathematical part of qubits. I will take you into the world of mathematics also. So we will see the applications of matrices and the role of matrices in the qubits, and then we will move on to construction and working of gates. Okay, I will stop this video here. In my next video I will come back with little more mathematics. Okay, thank you.